Welcome to Pumping Python. My name is Jacob Itegboje, and in this video, I will create a basic calculator that performs addition, subtraction, division, and multiplication. First, let me create the project. I'm going to call my Python create Python TDD script that was done in the how to create a TDD environment chapter. I give calculator as the name and let the script run. It's going to create a bunch of things for me and shows me failure, which is the expectation at the beginning. I change that to false, and then I'm green. Let me add my list of exceptions encountered. That was an assertion error. And then I am going to add a to-do list as a way to track my requirements. So I want to test importing. I want to test addition. I want to test subtraction. I want to test multiplication and test division. All right. The terminal responds to my changes, the changes I added, but they're not actually code. It's just comments. So we're still good. Tests are still passing. I am going to add an import statement for the calculator module that will contain the source code for the program. Say import calculator to import calculator.py. That passes. I can remove test importing. Time to add the first test. Let's test addition. So I add a test here. It says define test addition self.assert equal passing calculator to add 0, 1 and 1. The assert equal method of unit test or test case checks if two things are equal. The first value and the second value. So in this case, I'm comparing the value of when I call the add function of the calculator module and I give it 0 and 1, does it return 1? If it does, then they'll be equal. Right now, I get an attribute error because the calculator module has no attribute add. So I add a name for it. I say add in the calculator.py module, and I get a name error. I'm going to add the name error to my list of exceptions encountered. And then I define the add function as something. I just define it as none. I get a type error. It says non-type object is not callable. Add that to my list of errors. For an object to be callable, it needs to be a function or a class. I know that I can create functions with the def keyword, so I change the add name to a function, and I return none. The terminal shows me a type error. Add takes 0 positional arguments, but 2 were given. So in the test, 0 and 1 was given, but in my definition, I'm taking nothing. So I'm going to change the definition of add to take in 2 values, x and y. And then I get an assertion error saying none is not equal to 1. So when calculator.add is called with 0 and 1, we're currently getting none, which is not equal to 1. So I'll change none to 1, and we get a passing test. Fantastic. But wait a minute. Is it that easy? Do I just provide the expectation of the test to make it pass? In the green phase, yes. I do whatever it takes to make the test pass, even if I have to cheat. Solving the problem this way shows a problem with the test, which means I need to make it better. There are a few scenarios to consider from a user's perspective. What if a user tried to add a number that was not 0 or 1? The add function will still return 1. If they try to add negative numbers, the add function will return 1. This thing will always return 1 regardless of what you give it. It's a singleton function. So I need to add better tests so that the add function meets the requirement. First, I'm going to take away test failure because I don't need that anymore. I have a test here, and I'm going to add to this test for the scenarios that I just mentioned. So self.assert equal, and I say calculator.add -1, 1, and the expectation here is that we should get 0. But as discussed earlier, our function only returns 1. So I need to change it to do something with these two values. Python allows addition, so I can just say return x plus y. and my test passes. Great. So how can I make this better? The test-driven development mantra is red, green, refactor. So to make this test better, instead of having to do a case for each one, I'm going to use the random library and use random numbers. First, I import it. I say import random, and then I say x is equal to random.randint from -1 to 1. This is going to give me any one of three values, -1, 0, 1. I say y is equal to random.randint -1, 1. Same thing, I'm going to get a random number that's -1 or 1. And then I add them. When I add a random number between -1 and 1, do I get the addition of those two things? I don't need this anymore. And I still have a passing test. I now have random variables to represent all negative numbers and all positive numbers as well as zero. So I can say this is a test that covers any integers. Since I have passing test for addition, I have a passing test for addition. I can remove a test addition from the to-do list. Again, a reminder, the test-driven development cycle in practice is red. I write a failing test. You saw that with test failure and with the first test of the calculator function, of the add function and calculator module. Green, I make the test pass by any means necessary. And refactor, I make it better. I repeat this process until I have a working program that has been tested, which gives me confidence it works in a way that meets the requirements. Let's move on to test subtraction. I add a test, say test subtraction, self x is equal to a random integer between -1 and 1, y is equal to a random integer between -1 and 1. The expectation is that when I say self.assert equal and I call calculator to add x and y, I should get x minus y. I get an assertion, oh no, calculator to add, I mean calculator dot subtract, and I get an attribute error. Calculator has no attribute subtract, so I add the name, subtract, I get a name error, and then I define it as the null value. I get a type error when I make it a function. I get a type error saying I don't have the positional arguments or that it doesn't take positional arguments. I add them and I get an assertion error saying none is not equal to this subtraction of these two random values. So I change the function to return x minus y. And we are green again. I can remove test subtraction from the list of things to do, and I can make this better. There's a repetition here. I have x equals a random integer here in test subtraction, y equals a random integer here in test subtraction. I also did it in test addition. To remove this repetition, I can declare these things once and then reference them later. I can do that with class attributes. So I say x equals random, or randint minus 1, comma 1. I say y is random dot randint -1, comma 1, and then I reference them later by saying self.x, self.y, and self.x here, self.y. I get passing tests. I can do the same thing with the test for subtraction, self.y, self.x, self.y. And we have passing tests. All right. Fantastic. Time to move on to test multiplication. I had a test for it. Say define test multiplication self.assert equal calculator dot multiply self.x by self.y, and the expectation is that I get self.x times self.y. I get an attribute error because there is no function named multiply, or there's no name multiply in the calculator.py module, I add using what I've done so far, and I say return x multiplied by y. I made a mistake in the test, line 25, I did self.x times instead of self.x comma. And we have passing tests. So the addition function, subtraction function, and the multiply function all pass the tests, so I can remove test multiplication from the to-do list. Time to move on to the test for division. I had a test called test division, define test division, self.assert equal calculator dot divide self.x divided by self.y. The expectation is so I get self.x and self.y. Terminal shows an attribute error because I don't have a name a definition for divide in the calculator module. So I add a definition for a divide, say x comma y, return x divided by y. I made the same mistake I did with multiplication. I forgot to put a comma. And here we get a passing test. But the result changes depending on what y is. Since y is a random number between -1 and 1, it could be 0 sometimes. And in math, we do not have an operation defined for dividing by 0. So anytime y is 0, we should get an error. I hit save a few times, and we should eventually run into it. Here we go, 0 division error. Division by 0, y is 0, x is 0. So I add that to the list of errors, 0 division error. And then I need to add a test. There's a way to test for errors. I'm going to first make sure that I triggered this error exactly. I'm going to comment this out so that the variation goes away, and I say self.assert equal calculator dot divide. I say self.x comma 0 so that it always divides by 0. Self.x as this has 0. And I made a spelling error. Here we go. Still have an error. Test division return x divided by y. Oh, self.x. My mistake. All right, here we go. 0 division error. Now it's triggered, and I need to make it pass. Exceptions like 0 division error break execution of the program. No code is going to run past the line that causes an exception when it is raised, which means that no other test will run until I take care of this error. Time to make it pass. I can confirm errors by using self.assert raises. To do that, I do with self.assert raises, and the error we're checking or verifying or confirming is 0 division error. And we're saying whenever calculator.divide gets a 0 as its y variable or parameter, it raises a 0 division error. And we have a passing test. All right, very good. So that's how to catch an exception in a test. Now I need to update the test for division so that it never does this. It never divides by 0. And to do that, I say while self.y is equal to 0, self.y is equal to random.rand int -1, comma 1. What this does is creates a loop that any time y self.y is equal to 0, it should give it a new value between, it should either be -1 or 1. And then I can now uncomment my test, and we are green again. I can now remove test division from the to-do list and remove the to-do list entirely. That's it. Congratulations, you made it through writing a program that can perform the 4 basic arithmetic operations of addition, subtraction, division, and multiplication using test-driven development. You also encountered assertion error, name error, type error, and 0 division error. What would you like to do next? See you in the next one.